Robotic Process Automation, or RPA, may sound like a complicated robot, but it's really not. In fact, it has nothing to do with actual robots. RPA is simply software configured to perform repetitive tasks on a computer and usually targets the most time-consuming or expensive task an organization is faced with. It's typically front-end based, meaning that it controls your computer from the user interface and performs otherwise time-consuming tasks in seconds. RPA can automate a wide variety of tasks, from manual data entry to opening emails and extracting attachments. It performs these repeatable tasks using simply yes or no logic and a decision tree structure that tells the bot what to do next when faced with specific conditions. RPA can either be attended or unattended. Attended bots require human input at some point in the process and are typically run on employee desktops. Unattended bots are completely automated, programmed to run on a schedule, and are usually hosted in the cloud in a virtual machine or VM. But what RPA can't do is interpret data and react to it in real time. Doing that requires additional decision-making capabilities that fall under the larger umbrella of intelligent automation. Intelligent automation utilizes the same basic RPA structure, but introduces some additional technologies that complement RPA well. A few examples of these technologies that make up intelligent automation includes machine learning to recognize patterns in data over time, cognitive processing to make decisions based on incoming data, computer vision to identify and interpret images in real time, and finally, a natural language processing to understand the intent of a user's typed text. Combining these technologies to leverage their respective strengths can lead to much more effective solutions than would otherwise be possible with standard RPA. Something we can use to help illustrate this difference is by looking more closely at the architecture of a chatbot, like on an e-commerce store, for example. So in our scenario, a user typically converses with a chatbot using natural language processing to ask questions and determine the intent of an inquiry completely autonomously. Let's say our customer wants to check the status of his or her order, and they go to our chatbot for help. They'll ask, "What's the status of my order?" in the on-screen chat window. From here, it requires a few steps spanning across several technologies that need to be completed first before we can give our customer the answer they're looking for. First, the chatbot needs to verify who the customer is with the multi-step identity verification to ensure the person in our chat is, well, in fact, who they say they are. When the customer provides valid credentials, the chatbot passes the information along to an RPA taskbot to query and pull information from the SQL database where the customer data is hosted. The RPA taskbot in this example of intelligent automation is used as a middleman between the chatbot and customer to pull the relevant information from the desired source and return the results back to the chatbot where it is interpreted and relayed to the user. As you can see, intelligent automation amplifies a solution's problem-solving ability by employing a much broader range of technologies to perform a specific function that can contribute to or enhance the overall usefulness of the automation process. Thank you for watching and have a simply amazing day.